Hey guys, welcome to today's lesson. Today we're looking at index notation, index laws. So we're moving on from those last topics that we've been looking at with algebraic equations, but still there are going to be some similarities in what we do. A couple of first things, this is just revision from year 8, so hopefully you do remember some of these stuff. First of all, can you actually remember what an index is? Okay, let's start with an example of, let's talk about, let's say 2 to the power of 3. So hopefully you remember the word indice or index, which means like a power, right? And that's that thing up there. That's an index, that's an indice. Can you remember any other ways to talk about it? We said a power. It also means an exponent in America. It actually also means an order. So think about that bid mass, bed mass, bod mass kind of thing. Okay, that's what indice is. It's to this power. The 2 in this instance is what we refer to as the base of our number. So what does 2 to the power of 3 actually mean? So hopefully we remember in expanded form, it means we're multiplying 2 by itself, but we're multiplying in this instance 3 times. So the power tells me how many times we are multiplying it by itself. So if we had 4 squared, it'd be 4 times 4. If it was 5 cubed, 5 by 5 by 5. If it was 9 to the power of 10, it'd be 9 times 9 times 9, 10 times. So that's what our indices are. So what we're looking at and quick reviewing today is how we might write something like 5 times 5 times 5 times 5 in index form. Pretty basic. You did that in year 7, year 8. Hopefully you would just say, hey, that's 5 to the power of 4. And that's no problems at all. But what if you have something that looks like this? A to the power of 3 times a to the power of 2. Now you might remember in year 8 going through some of these laws. Fast ways of doing this, you might be shouting at me saying, sir, I know the answer. I hope you do. But let's say I don't. Okay, what does a cubed actually mean? It means a times a times a. A squared, we know, means a times a. So we've got our a cubed times a squared. Now you notice now, when I expanded it, they're all just being times together, which means I actually have 5 of them being multiplied together, which means I have a to the power of 5. Now, let's have a look at our question and look at our answer. Is there another way that we could do that without having to expand our numbers? You know, I'm hoping, again, those people are yelling at me saying, sir, I know a quicker way. Okay, you would have recognized that if the base is the same, they're both a's, and we're timesing, we can add the powers. 3 plus 2 makes 5. Now, last year, you would have looked at this law. Okay, now it looks weird, okay, but it's just a bit of a general rule to show that when the bases are the same, both a's, and you're timesing them, then we simply add their powers. So if we have a question, I guess as an example, that looks like this, 5a to the 4 times 2a to the 3, we can first of all multiply the big numbers. 5 times 2 is 10. And because the bases are the same and we're timesing them, we can simply add the powers, and that gives us a to the power of 7, and that would be a simplified answer. Now, of course, if you really don't get that, you could break the a's up like that. Okay, and then again, a by a, and then put a times in between, and now you can still got 7 of them. But certainly we should be pushing ourselves in year 9, year 10 to getting that answer straight out. So that's the first law. I'm going to put that in yellow. I want you to remember that in your books. That is something that you should have down as a law, as your part of your notes. Now, the third thing we're going to look at before we get on to some of these questions is going to be what happens when we divide. So for example, when we do something like this, a to the 4, actually we'll just say a to the 5. How's that? That's like a to the 5 divided by a to the 2. What would you do there? So there's a couple of different things you might be thinking. First of all, you might be thinking, I'm going to divide the 5 and the 2 and make it 2.5. Doesn't really sound right, does it? So like we did that last question, and hopefully you might be saying, so I know the answer. Awesome if you do. But let's just expand it out like we did that last question. That's what a to the 5 means, right? Now I could do a little divided by sign, but I'm actually going to use the fraction sign, which we know to be the same. I'm going to put a times a underneath. Means the same thing, right? Now, I'm going to ask you the question. What happens when you divide two numbers that are identical? So 5 divided by 5, 10 divided by 10, 100 divided by 100. Hopefully you tell me the answer is 1. Okay, so in that case, what's A divided by A? 1. Now, technically speaking, the answer when they divide them is 1, but because 1 times anything is just itself, technically speaking, these will cancel out. For example, A divided by A will also cancel out. And now what I'm left with are these 3a's being multiplied together by itself, which means it's A cubed. Don't think it's 3 times A. That's the different thing. That's 3 times an A. Here we're doing A times A times A, therefore it's A cubed. So that's my answer. Now, likewise before, can you kind of go from the question directly to the answer in a really quick way? Now, hopefully, again, some of you were yelling at me before saying, sir, I know a quicker way. You might recognize that 5 subtract 2 makes 3, which then brings us, of course, into this rule here. When you are dividing two terms, the bases are the same, we can subtract our powers. So a to the m minus n. And again, gents, that would be a really useful thing for you to write down in your books to make sure that we have some quality notes there of those rules. Now, again, some of you are going, so I know how to do this. I did this last year. Super easy, but you might not remember that. They're the only two rules that we're looking at today. Okay, next lesson, we'll start looking at the exponent law and the power of 0. Then we'll go into negatives. Now, what I'm going to do here, gents, is I've got, 1, 2, 3, 4, 5, 6 questions for you to do. I want you to pause it. I want you to have a go at these questions, and I want you to play it and hopefully see if you've got it right. Once you've got that, we can go through the actual answers, and then you can do the questions for them today. All right, so how did you go? So straight away, I recognize here that the bases are the same. So we both have A's. We're being multiplication, so I'm simply going to say A 6 plus 7 is 13. A to the power of 13 is my answer. Guess what? That's done. Highlight that. Job done. Let's move on. The next question, same thing, but we're now dividing. The bases are the same. So instead of adding them like we did with the multiplication, opposite of times is divide, opposite of plus is minus, we're now going to subtract the two powers. And I'm going to get 6 minus 2 is 4. Be really careful. A lot of boys want to divide the powers and make it 3. Not the case, okay? Again, remember, we have 6 of these things being times together. A little bit hard to see when I'm doing like that, isn't it? 1, 2, 3, 4, 5, and 6. And I'm dividing it by 2 of them. Of course, that means 2 cancel out, which gives me the 4 left over. So don't forget about that. Okay, the next one, a little bit harder. Let's multiply the numbers first of all. 3 times 2 makes 6. The powers, the bases are the same. So let's add them. Done. Hopefully you got it right. Next one, 30 divided by 10. Well, that makes 3. Now, we have c to the power of 4 divided by c. Now, I don't have a power there, do I? But actually, it is a power. It's the power of 1. So 4 take away 1 is 3. So we have 3c to the 3. Okay. So again, 30 divided by 10 is 3, and then I have c to the power of 3. Now, again, if you're not sure when you're doing these like that, just rewrite it like that. 30 divided by 10 is 3. Put a 1 there. 4 minus 1 is 3. And again, you can see the answer works out quite nicely. Once again, if you're not sure about the c's, see how if I expand it out, only one of them now cancel out. Hence, I had the C3 there. Oh, that's starting to make sense. E and F, slightly harder, hopefully not too much harder. Okay, multiplication. 5 times 2 is 10. 10 times 3 is 30. Beautiful. Dealt with my numbers. Let's now deal with letters. We have a few different letters here, don't we? We don't just have the same one. So in this instance, we have d to the power of 4. We have another d over here and a d to the power of 6. I've got 3 different d's being multiplied together. So let's add the powers. 4 and 6 is 10. 10 and 1 is 11. So I have d to the power of 11. Now the two c's, well, they're both c times c, or 1 and 1. 1 plus 1 is 2. And we know, of course, that c times c is c squared. It works out. That's my answer. And the last one, 10 divided by 5 makes 2. 4 take away 2 is 2. And 6 take away 1 is 5. And now that becomes my answer. And I just want to throw in just one little one. I'm going to put 5a to the 6 divided by 15a to the power of 2. Slightly harder. I don't know if you recognize why, and it's not actually the algebra in this case, because you know these ones, 6 and 2, well, 6 take away 2 makes 4, right? So I know that it's going to be a to the power of 4 when I do it that way. Again, 6 on top, 2 on the bottom, 2 cancel out, 4 on top left over. My issue is going to be with this. What's 5 divided by 15? Doesn't work too well, does it? So what I'm going to do is this. 5 goes into 15 3 times. 5 goes into 5 1 time. I've actually got 1 over 3. And so you can see there that that's my answer, or I could write it as a to the 4 over 3 as well. Okay, I hope that made sense. Okay, again, often we struggle with these, particularly in 5-2. So please go through the answers today, go through the questions, make sure you can do the work. I've given you a worksheet today as opposed from textbook stuff. So just see how you go. Any problems, of course, ask some of your classmates or send me a message on Canvas. Have a wonderful day, gents. Hopefully you noticed, World's Greatest Shave, support the cause. Have a great day.